Hey everyone, and welcome. Today we're going to pull back the curtain on one of the most powerful technologies literally shaping our world, deep learning. So let's just dive right in. Okay, think about something you probably did about 5 minutes ago. You pick up your phone, glance at it, and boom, it's unlocked. How on earth does it know it's you and not someone else? Or what about this? You ask your smart speaker for the weather. It doesn't just hear a bunch of sounds. It understands your actual words, your accent, your intention. I mean, how does that even happen? And we've all had that slightly spooky moment, right? Your streaming service recommends a show you were just thinking about. How does it get so good at predicting what you'll like? Well, the common thread, the secret sauce behind all these modern marvels, is a very specific and incredibly powerful form of artificial intelligence called deep learning. It's the engine driving some of the smartest technology we use every single day. To really get a handle on what deep learning is, we first have to zoom out and see where it fits in the bigger picture of AI. Think of it like a set of Russian nesting dolls. It's all about understanding the layers. So at the very top, the biggest doll, you've got artificial intelligence, or AI. This is the big, overarching idea, the quest to build machines that can think, reason, and learn in ways that seem, well, human. Now you open that big doll, and inside, you find the next one, machine learning. This is a specific branch of AI. Instead of programming a computer with a million rigid rules for every situation, we just give it a whole bunch of data and let it figure out the patterns for itself. It actually learns from experience. And this brings us to the very center of it all, deep learning. It's a specialized, kind of supercharged version of machine learning. The key thing to remember is that it isn't a replacement for ML. It's an advanced extension of it. And its secret weapon is something called layered neural networks, which let it tackle insanely complex problems. So how do these neural networks actually think? Well, the core idea is pretty brilliantly inspired by the most powerful computer we know of, the human brain. And this isn't just some casual comparison. The entire structure is literally modeled on our own neurology. These artificial neural networks are made of interconnected nodes. You can think of them as artificial neurons that process information in stages or layers. Let's make this concrete. Imagine you show the network a picture of a car. Okay, the first layer of neurons doesn't see a car at all. It just sees simple things, lines, curves, patches of color. Then the next layer takes those basic features and starts combining them into more complex shapes, like circles that might be wheels or rectangles that could be windows. Deeper layers keep assembling these shapes into bigger concepts until finally the output layer puts it all together and says, that's a car. It's this beautiful hierarchy of understanding, going from the simple to the complex. So what gives deep learning its superpowers? What lets it do all these incredible things? The secret, in just one word, is data. A truly mind-boggling amount of it. And this, right here, is the key difference. With traditional machine learning, you eventually hit a wall. Adding more data doesn't really make the model much smarter. But with deep learning, it's the exact opposite. The more data you feed it, the more accurate it gets. Its appetite for data is basically limitless. And so is its potential to learn. This hunger for data is a huge deal, especially when you realize that a staggering 80% of the data in our world is unstructured. What does that mean? It means it's messy. It's not organized in a neat little spreadsheet. It's all the photos, videos, audio files, and text out there. And this chaos is exactly where deep learning shines. It can make sense of all the complex stuff that older algorithms just can't. We're talking about images and video, raw audio clips, the nuances of how we actually speak, and continuous streams of sensor data. Deep learning is built to find the patterns hidden in the noise. Okay, so let's look at how this technology actually shows up in the real world. You might not even realize it, but I guarantee you're interacting with deep learning systems constantly. They are all around you. That phone unlock we talked about, that's deep learning-powered computer vision. And that very same technology is also helping doctors analyze medical scans, spotting signs of disease with an accuracy that can sometimes surpass the human eye. Anytime you talk to a voice assistant or see your words magically pop up on the screen during a call, that's a deep learning model interpreting the complex sound waves of your speech. It's the magic behind those smart chatbots that can actually understand your problem. And it's why you can point your phone's camera at a sign in another language and get an almost instant, coherent translation. It's incredible. And then you get to the really sophisticated stuff. Deep learning is what allows self-driving cars to actually perceive the world around them, identifying pedestrians, other cars, traffic signs, all of it in real time.
So, let's just bring it all together. What is the fundamental difference here? What's the thing that makes deep learning such a massive leap forward for the entire field of AI?
This table really nails the key differences, but the most important one, the real game changer, is that line called feature engineering. See, in the old days, human programmers had to manually tell the machine what features to look for, like the curve of a car's fender or the shape of an eye. Deep learning does this all by itself. It learns what to look for, and that self-sufficiency is what makes it so incredibly flexible and powerful. So at the end of the day, what this all means is that deep learning isn't just some small upgrade. It's a fundamental shift, a whole new way of building intelligent systems that are much more sophisticated and, well, a lot more like us. By giving machines this incredible ability to learn from the raw, unstructured data of our world, we've basically given AI a new set of senses, a way to see, hear, and understand on its own terms. Which really just leaves us with one massive question. What will it learn to do next?